Hi, in this video I'm going to show you how to find the volume of a solid that has been revolved around the y-axis. So for instance, we have this solid here, we're going to revolve this around the y-axis, and I want to show you what that looks like. So we have the same graph drawn on GeoGebra, and we're going to revolve this around the y-axis so you can see the solid it's creating, and it's the volume of this solid which we're going to find. Okay? And this is the formula which we're going to use. Now I showed you in a previous video where this comes from, but in this video I'm just going to show you how we use it for complex functions such as this. Okay, so we've been given that the volume is equal to pi times the integral between the limits of a and b, and you can see that these limits are at 0 and 8, so we'll put these into our integral. And the function is x squared, which we're going to integrate with respect to y, so dy. So our first problem is to work out what x squared is from this function given in terms of y. So the first thing we can do is divide both sides of this by 4. So we get y over 4 is equal to a natural log of x minus 2. And now we need to cancel out the natural log. So we'll raise e to the power of both sides. And this will give us e to the power of y over 4 is equal to, and this e and natural log will cancel, because when you raise e to the power of a natural log, these two will cancel to make 1. So then we have x minus 2. And to make x the subject, this will be e to the y over 4 plus 2. But we need x squared, so we need to square this. So x squared will be e to the y over 4 plus 2 all squared. But this is difficult to integrate, so we'll expand these brackets out. So this becomes, so now we get x squared is equal to e to the y over 4 multiplied by itself, and this is e to the y over 2. We get this term multiplied by 2, and again, so we get 4 lots of e to the y over 4, and then we get 2 times 2, which is 4. So it is this which we'll put into our integral here. So we get the volume is equal to pi times the integral between 0 to 8 of e to the y over 2 plus 4e to the y over 4 plus 4, integrated with respect to y. So when we integrate this, we get v is equal to pi, and then we integrate e to the y over 2, and using the reverse chain rule, this becomes 2e to the y over 2. Again, using the reverse chain rule, this becomes 16e to the y over 4. And when we integrate 4, we get 4y between the limits of 0 to 8. So now we'll substitute in the limits of integration. And just to make this clear, we'll do the 8 in green and we'll do the 0 in yellow. So we get the volume is equal to pi, and then we'll substitute in the 8, so we get 2e to the 8 over 2, which is 4, so 2e to the 4, plus 16e to the 8 over 4, which is 2, so e to the 2, plus 4 lots of 8, which is 32. And then we'll close that bracket. Minus, and when we substitute in the 0, we get 0 over 2, which is 0. E to the 0 is 1, so this just becomes 2. Again, for our next term, we get 0 over 4, 0, so this is 1, so we get 16. And then 4 lots of 0 is 0, so we'll close that bracket and the final bracket as well. So now this becomes v is equal to pi times 2e to the 4 plus 16e squared plus the 32 minus the 2 minus the 16. So this gives us our volume is pi lots of 2e to the 4 plus 16e squared plus 14. And I'll leave it in that form so it's exact. And this is in units cubed. Okay, let's try another question. Okay, so in our next example, the diagram shows the part of a curve with this equation, x squared is equal to e to the cos x sine y, where x is greater than or equal to 0. And we've been asked to find this shaded region revolved around the y-axis to give us a solid of revolution. So the first thing we need to do is to find the value of a. So at a, we know that the x value of a y-axis is 0. So we can substitute this 0 into here. So 0 squared is equal to e to the cos y sine y. And now I can divide both sides by e to the cos y. This will make 0 and these two will cancel. So now we've got 0 is equal to sine y. We'll take the arc sine of both sides. So y is equal to the arc sine of 0. So y is equal to pi. Okay? So I'll write pi at that upper limit here. So now we've got our limits between pi and 0. We can substitute these two limits into our formula for a and b, and we've already been given x squared, which is this. So now we can rewrite this integral. So our volume will be equal to pi times the integral between pi and 0 of x squared, which is given here. So e to the cos y sine y, integrated with respect to y. Okay, so this might look quite confusing, but if we think about the reverse chain rule, if we were to differentiate this bigger function, well then the chain rule would tell us differentiate y. So that means we would get e to the cos y sine y, but we would also have to scale it. So what I'm going to say is, if we let w equal e to the cos y, and we found dw by dy, then we get the derivative of cos minus sine y times e to the cos y. And it is this negative which we need to scale. So we need to multiply both sides by -1. And if we did this, then this would look exactly like the integral we're trying to find. So this tells us that this integral will be -e to the cos y. So we can say the volume is equal to pi, and then the integral minus e to the cos y between 0 and pi. So now we'll substitute in our limits. V will be equal to pi times, we'll do this one in yellow, so -e to the cos pi. We'll do this one in green, minus -e to the cos 0. So the volume will be equal to pi multiplied by, well, because of pi is -1, then this becomes -e to the -1. And then this negative and this negative make a positive. And because of 0 is 1, so that just becomes plus e. And we can tidy this up. So we get v is equal to pi times e minus 1 over e. And if we write this e as e over 1, and we can simplify this, so our volume is equal to pi times e squared minus 1 over e. And this is exactly what we were asked to find here. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. The link in the description below. Thanks again and take care.